Hi, Assalamualaikum warahmatullahi wabarakatuh. So today I'm going to explain on the calculation for experiment 6 pH measurement and its application. So because some of you guys, most of you guys memang tak masuk lagi this chapter 7. So I think I need to do a video for you to understand how to calculate it to answer the exercise question. So if you go to your lab manual, you can see that there are two exercise questions that you need to answer and do the calculation. So let's look at the first one. So first one is it asks you to calculate the percentage of ionization of 0.1 molar and 1.0 molar acetic acid. And how does the percentage of ionization change with its concentration? Okay, so we do the first one first, A for 0.1 molar. So if we look at here, from part A, pH of 0.1 molar acetic acid CH3COOH. So this is where you got your pH in your part A experiment. So I have given to you the table consists of the pH measurement for the part A, right? So from part A, the pH for 0.1 molar acetic acid is 3. Okay, it's 3. Okay, so as you know, pH is equals to negative log H plus. So H plus is equals to, so it's equal to 3 lah kan? Okay, so H plus is equals to, tekan calculator. So how you want to tekan calculator? Okay, so you know dalam calculator. Okay, so you know pH is equal negative log H plus kan? So kat sini, you bawa dulu log H plus is equals to this negative, you bawa pergi pH. So equals to negative pH. So in this case, log H plus is now equals to negative 3. So sekarang ni kita nak kira H plus, betul? So concentration of H plus is equals to, log is base 10, right? So 10 to the power of negative 3. And then you will get the concentration of H plus is 1 times 10 to the power of negative 3 molar. Okay. Okay, so you now have got your concentration of H plus from the pH of 0.1 acetic acid. So this is how you do, Okay. So now, you know the ice table from chapter 6.2. So you are going to use that one. So you know the the initial molarity for CH3COOH is 0.1. This one kan, 0.1. So it is 0.1. And the initial for the product is 0, 0 lah. We tak mention, so we assume it's 0. So the change here, since reactant is always minus, so dia tak ada stoichiometric coefficient in front of this, so just minus X. Assume dia satu je, okay? So kat sini plus X, kat sini plus X. So dekat sini, to get the equilibrium, I plus C, so 0.1 plus X, so 0.1 plus negative X, so minus X lah. So kat sini X, kat sini X. Okay. So now, we know that here, X here is equals to concentration of H plus. So X here is equals to concentration of H plus, and you already know the concentration of H plus is 1 times 10 to the power of negative 3 molar. So X is equals to 1 times 10 negative 3 molar. So you need to find the degree of dissociation or the ionization where the CH3COOH will dissociate kan. So dia kata calculate the percentage of ionization, maksudnya dissociation of acetic acid. So X here, okay, yang dah dissociate ni, so X here is 1 times 10 negative 3. So 1 times 10 negative 3. C here is initial concentration. So initial concentration. So initial concentration is 0.1. So 1 times 10 negative 3 molar divided by 0.1 molar is equals to molar. Ini pun molar. Right? But cancel jadi apa? So 1 times 10 negative 3 divided by 0.1 is equals to 1 times 10 negative 2. So this is the degree of dissociation for acetic acid. But it went in terms of percentage. So we just times with percentage. So 1 times 10 negative 2 times 100% is equals to 1%. So this is how you find the percentage of ionization for CH3COOH. Okay, now that is for 0.1 molar. So let's do for 1.0 molar. Okay. So from part A, the pH of 1.0 molar acetic acid is from the table yang I bagi dalam result dalam telegram, it is 2.5. So you know that pH is equals to negative log H plus is equals to 2.5 kan pH dia. So by using calculator, you can use that pH is equals to, this one, you can see that here. Log H plus, okay, you bring the negative into the pH punya value, so dapat negative 2.5. So H plus here now, log is base 10 is equals to 10. This one bawa pergi atas sini, negative 2.5. You will get 3.16 times 10 to the power of negative 3 molar. So let me check the calculation again. Did I make a mistake? Okay. Alright, no, this is correct. Okay. So here we already know that the concentration of H plus is 3.16 times 10 negative 3 molar. Apa benda ni? Okay. So now we are going to do the ice table again. So we know that the initial concentration of acetic acid for this one is 1.0 and this one is 0 and this one is 0. Okay, I salah pilih pen. This is 1.0, this one is 0, this one is 0. And the change here is negative x, this is positive x, positive x. So the equilibrium here is 1.0 minus x, this one is x, this one is x. Okay, and we know that the x here sama dengan concentration of H plus kan? So x here is equals to the concentration of H plus, where we know that the concentration of H plus is 3.16 times 10 to the power of negative 3. Okay, so we already know that. So that's why we can use for the degree of this dissociation alpha is equals to x divided by the amount of dissociated of CH3COOH divided by initial concentration of CH3COOH, acetic acid lah. Okay, so we know x is equals to 3.16 times 10 to the power of negative 3 molar divided by initial concentration there 1.0 molar. So cancel the unit. So we will get it as 3.16 times 10 to the power of negative 3. Tak ada unit dah. Sorry. 3.16 times 10 to the power of negative 3. So this is the degree of dissociation alpha. So we can but the question one in terms of percentage. So 3.16 times 10 negative 3 times dengan 100%, you will get 0.32%. Okay, tadi soalan dia nak cut. So, tadi soalan, it asks you to state the relationship kan? So, it asks you for the question, it asks you to, how does the percentage of ionization change with its concentration? So, if you look at here, when the concentration is increases 1.0, the percentage of dissociation decreases compared to the when the percentage of when the molarity is low 0.1, the percentage of dissociation is quite high 1%. So we assume that here percentage of ionization CH3COOH increases as the concentration decreases, kan? Sebab bila concentration lagi rendah, percentage of ionization lagi tinggi. So this is the relationship between the percentage of ionization and its concentration. Okay, so this is how you calculate lah. Okay. Okay, now for question number 2, it says that refer to pH value of acetic acid in part A. So, part A yang tadi tu, table tadi tu, dengan question 1 tadi. Calculate its Ka and compare this value to that obtained from part C. Okay, so kita nak kena compare from part C lah. So, kita kira part C dulu berapa. Okay, so from part C ni eksperimen yang buffer solution tu, remember? Yang dia nak, from weak acid tu. Okay. So, from the, what we call it, result table that I have give you in Telegram, the pH of buffer solution obtained is 5. Okay. So, dekat sini, pH dekat sini 5. So, you need to find lah, dia nak find Ka kan. So, dia nak compare Ka yang part C dengan Ka from part A. Okay, so kita kira from part C dulu. So, if you look at experiment from part C, the experiment asks you to, dia ada 2 conical flask here. Okay. Flask X dengan flask Y both contain CH3COOH. But for flask X, you need to titrate with sodium hydroxide. Okay, so for the equation, we will see that CH3COOH plus sodium hydroxide will have CH3COO and A plus H2O. So this is your chemical equation for the experiment in part C. So it gives you that the molarity of acetic acid used is 0.1 molar and the volume is 25 ml. So you can find the number of mole. So we assume that the number of mole of acetic acid is equals to the number of mole of salt, which is here I have calculate the number of mole of CH3COOH equals to 0.1 times 0.025 liter is equals to 2.5 times 10 to the power of negative 3 mole. So the number of mole of acid and salt is 2.5 times 10 to the power of negative 3 mole. Okay, so now we know that the pH is equals to pKa plus log concentration of salt divided by concentration of acid. So we need to find the concentration of salt and acid. Okay, so the new concentration sebab dia dah after reaction, right? So to find the concentration of acid, we need the number of mole divided by volume total. So the number of mole is the same here. We already got here. So the number of mole here is 2.5 times 10 to the power of negative 3. So divide by volume total here is the total volume that you use during the experiment in part C. So you know that the flask X containing the acetic acid is titrated with sodium hydroxide, which is 13 ml. This is 25 ml. So titrate this one, okay, to get the CH, to get the salt, okay. And then you add another 25 ml of acetic acid from flask Y into flask X. So now you got 13 ml plus 25 ml plus 25 ml, you will get 63 ml total, which is 0.063 liter. So now you got the total volume here is 0.063 liter. So here you will get the concentration of acetic acid here is 0.3968 molar. Okay. Okay. Same goes to the concentration of salt. Just now I said that the concentration of salt is equal to the concentration of acid. Right. So now the concentration is the same lah. Okay. 2.5 times 10 to the power of negative 3 mole. Divide by total volume pun sama kan. So 0.063 liter. You will get the same concentration for the salt as well. 0.3968 molar. Okay. Alright. So now you have gotten both of the concentration. You know that pH is equals to pKa plus log salt over plus log concentration of salt divided by concentration of acid. So here pKa is actually equals to pH minus log concentration of CH3COONA divided by concentration of CH3COOH. So pH tadi berapa? 5 kan tadi dalam result kita dapat minus dengan log. Okay, concentration tadi 0.3968 0.3968 divided by 0.3968. So we will get equals to, K ni besar sebenarnya, asal kecil sangat aku buat ni. So it's actually like this. pKa macam tu. So 5 minus, so log ni dah kira 1 lah kan, betul? Kira 1. So log 1 is equals to 0. So 5 minus 0 is equals to 5. Okay, so we got the pKa, but it is not yet Ka. So we got the pKa equals to 5. So we know that pKa is equals to negative log 10 Ka. So Ka is equals to 10 to the power of negative pKa, because we use the calculator, we know that log is what we call it, because this negative we put we change the negative, we pindahkan, we transfer the negative into the pKa ni, so dia nanti jadi negative pKa macam tadi kita buat. So now log 10 is base 10, so 10 here, then kita bawa pergi sini, so 10 to the power of negative pKa to get Ka. So now we know that 10 is equals to negative 5, 10 to the power of negative 5. So Ka will be 1 times 10 to the power of negative 5. So this is your Ka from part C. Okay, so now we need to calculate from part A dengan question 1 tadi, compare dengan part C kita tadi ni. Okay, so here we already know that from part A and question 1, if the molarity of acetic acid is equals to 0.1 molar, the pH is equals to 3. So we know that X yang from question 1 tadi is equals to concentration of H plus is equals to 1 times 10 to the power of negative 3 molar. So, we know that to find the Ka, it is equals to the concentration of product over concentration of reactant. So, kita dah tahu ini semua X, ini 0.1 minus X from the ice table. Okay, kalau lupa ice table, kita tengok balik ice table question 1 tadi. Okay, this is ice table for question 1. Kita tengok yang dekat equilibrium sini, okay? Kita yang kat sini. So, Ka is equals to concentration of CH3COO minus times concentration of H plus divided by concentration of acetic acid. So, X times X divided by 0.1 minus X. That's why we got that kind of expression for Ka. Okay. So, this one, we got this one. Then we substitute lah the value kan. So, the value of X is 1 times 10 to the power of negative 3. So, 1. So, here, kita jadi X squared divided by 0.1 minus X. So, 1 times 10 to the power of negative 3 squared divided by 0.1 minus 1 times 10 negative 3. Ka is equals to 1.01 times 10 to the power of negative 5. Okay, so this is what you get lah. Okay, same goes to when the molarity for acetic acid is 1.0. So for B, here, if the molarity of acetic acid is 1.0 molar, we know the pH is equals to 2.5. So from the question 2.1 just now, the concentration of H plus is equals to 3.16 times 10 to the power of negative 3 molar, which is equals to X. So, to find Ka, sama juga macam yang step A tadi, dekat soalan A tadi. Concentration of acetic ion times dengan H plus divided by acetic acid. So X times X over 1 minus X. Sebab tadi initial dia dah jadi 1 kan. Sebab dia punya molarity kita sekarang ni 1.0. So sekarang jadi X squared minus 1 minus X. So Ka is equals to 3.16 times 10 to the power of negative 3 squared minus 1 minus 1 minus 3.16 times 10 to the power of negative 3. So you will get the Ka is equals to 1.0 times 10 to the power of negative 5. So, the question just now asks you to compare the value of Ka from question 1 part A with part C. So, we can say that the Ka value obtained from part A and C should be almost the same. Sebab apa ni 1.0 times negative 5. Yang atas ni pun 1.01 times negative 5. And part C, we get Ka 1 times negative 5. So, the value of Ka is the same. So, what is the conclusion from this experiment that you got? So, actually, the value of Ka for weak acid, because acetic acid is weak acid kan? For weak acid, will remain constant and does not depends on the molarity at all. Okay, nampak tak constant? Dia tak depend on molarity pun. Okay, so that's the conclusion lah kan? So, the Ka value for the acetic acid is constant and does not depends on the molarity. Okay, so you already get the Ka value for acetic acid is equals to 1.0 times 10 to the power of negative 5. Okay, so that is all for the calculation for exercise question 1 and 2. So, I have already give you the result table for part A, part B and part C punya eksperimen dalam group Telegram. And you need to do the answer for exercise under the discussion, and the discussion for part B I already put on the Telegram as well. Okay, so yeah, that's all for today. I hope that you understand how to calculate the KA for experiment 6. So that is all. Thank you. Assalamualaikum.